All right, so let's get into some more perimeter and area problems specifically for the parallelogram. And just a reminder, the area of a parallelogram is your base times your height. So check out that diagram. Base is the length and the height is like the width, and it's similar to your area of a rectangle. So the first thing that you would need, especially for the perimeter, is the length of all the sides. I love it when a shape has something where I can count vertically or horizontally the length of a shape. So for example, we have AB I'm looking at. I count the boxes across. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the side length of AB is 12. And similarly, if I looked at DC, I can count all the boxes across, but I know that for a parallelogram, and you will know this in later units as well, opposite sides are congruent, meaning the same length, so DC is also 12. Again, you can still just count. Okay, from here, I've got now boxes that go through the diagonal. So there's one of two methods that you can choose to do. You can either do the Pythagorean Theorem, or you can do the distance formula to find those lengths. I'm going to choose to do the distance formula because I like that I'm given the points, and I think the graph is a little bit tricky to read. So for me, another thing is I know that AD and BC are going to be the same length because it's a parallelogram again. But you can calculate the distance formula for both AD and BC, and you will determine what those lengths are. Hey, sorry, my phone was ringing. Had to answer that real quick. So we're going to do the distance formula for BC. I like to write what my points are going to be first, so that's my point B. And then C is 5, -4. And the distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and I like to choose first what my x1, x2 are, or excuse me, my x1, y1 and my x2, y2. So x1, y1, x2, y2. It doesn't matter which one is x1, y1, which one's x2, y2. And we're just plugging in those or substituting those values in. So we have 5 minus 10 squared plus -4 minus 3 squared. That becomes the square root of -5 squared plus -7 squared. Anytime you square a negative number, it becomes positive. 25 plus 49. That's going to give me the square root of 74. And if I hit that double arrow button in a calculator, I'll find that that length is actually the square root of 74. I'm just plugging it into my calculator, is going to be 8.6. The square root of 74 is 8.6. So that means that side BC is 8.6, and because it's a parallelogram, side AD is 8.6. To find the perimeter, I'm going to move my slide down a little bit, but perimeter, I'm going to put it at the bottom left so don't get too confused. That's going to be all the sides added together. And that ends up being 12 plus 12 plus 8.6 plus 8.6, 41.2. And I want to always make sure that I have units. So notice that it says let each unit be represented by 1 centimeter, so that means the perimeter is 41.2 centimeters. For the area, it is the base times the height. Okay, the height is actually just this vertical drop down. So I can go ahead and I can count all those boxes to find what the height is. 1, 2, 3, 4, 5, 6, 7. So I found that my height is 7. My base I already calculated is DC, so that's going to be 8.6. Oh, wait, DC, sorry, 12. So 12 times 7. That's my area, which is 84. And area is measured in square units, which means I'm multiplying a centimeter times a centimeter to get centimeters squared. Okay,